Welcome to this explainer. Okay, listen, if you've ever felt completely overwhelmed by trigonometry, you are absolutely in the right place. Today, we're going to transform how you see this whole subject. We're going to take it from a mind-numbing chore of rote memorization and turn it into a fascinating, beautifully logical story of mathematical discovery.
Picture this. You're sitting in a classroom staring blankly at a chalkboard covered in 20 complex, seemingly unrelated formulas. Yeah, your heart sinks, right? It's that sheer terror of having to memorize a giant, jumbled bag of math just to pass a test. I mean, we've all been there. Memorizing 20 completely different equations, that is a massively tall order for anyone.
But what if I told you that you actually don't need to memorize 20 formulas? What if you only really needed to know 4? The massive paradigm shift we're going to explore today is that these 20 daunting formulas, they're not isolated rules at all. They're actually an interconnected family tree, built entirely from just 4 simple foundational parent ideas.
All right, section 1. Angles are just turns. This is our first big idea.
So, to see how this family tree grows, let's just totally forget about complicated triangles for a second. Instead, I want you to imagine a little arrow pointing right. You turn it, and boom, you get an angle. Turn it again, you have another angle. Angles are literally just turns. Now, first up is sine. Whenever you turn that little arrow, sine simply tells us about the up and down part of that turn, like how much vertical movement actually happened. That right there is sine.
Next up is cosine. So if sine is the vertical stuff, cosine tells us about the left and right part of a turn. It simply tracks your sideways movement. Super easy, right?
And rounding out our core trio is tangent. Tangent basically just takes those first 2 ideas and compares them. It tells us about the upward movement divided by the sideways movement, up compared with right. And that's it. That is our foundational vocabulary.
Section 2. The robot on a circle. This is the most important rule.
Okay, let's dive into this one. The absolute king of trig formulas is sine squared alpha plus cosine squared alpha equals 1. Now, why is this true? Well, imagine a little toy robot walking from the center to the edge of a circle that has a radius of exactly 1. To get to that edge, the robot has to move a certain number of steps sideways, which is our cosine. Then it moves a certain number of steps upward, which is our sine. Now, because of how right angles work, the sideways movement squared plus the upward movement squared is always going to equal the radius squared. And since our radius is exactly 1, well, cosine squared plus sine squared equals 1. See? You don't actually need to memorize it, you just need to picture that little robot.
Moving on to section 3, combining multiple turns. Let's talk about adding angles.
Let's see how this builds when we start combining things together. Like, what happens if we make 2 turns? Well, the sine of 2 turns combined can actually be built from the sine and cosine of each turn measured separately. Think of it like the second turn taking the direction of the first turn and just moving it along. The really brilliant memory trick here is that when combining turns for sine, you keep the same sign. If you're adding angles, you add the pieces. Makes sense. But for cosine, the sign actually changes to its opposite. A plus literally becomes a minus. And you might be wondering, why on earth does it do that? Well, remember, cosine measures the sideways part. When you combine 2 turns, some of that sideways movement actually gets changed into vertical movement, so that contribution has to be subtracted away.
Section 4. One idea, many dresses. Time for the double angle formulas.
So we've just seen what happens when we add 2 different angles. But wait, what happens if we make angle beta the exact same as angle alpha? You get the double angle formulas for cosine. Now, in most textbooks, they're written out in 3 completely different ways that you are just forced to memorize. But they really aren't 3 different formulas. This brilliantly illustrates how it's basically just one core mathematical idea wearing 3 different dresses. If you take our addition formula and just make both angles the same, you get the first dress. Then, if you mix in our little toy robot formula, where sine squared plus cosine squared equals 1, you can easily swap things out to create the other 2. It's honestly just a brilliant mathematical illusion.
And you know what? That exact same playful logic applies to tangent and cotangent. Tangent is sine over cosine, so just think of cotangent as 2 friends who decided to swap their clothes. Literally just flipping the fraction upside down so it becomes cosine over sine. Once you know how to build tangent with the up movement over the sideways movement, cotangent naturally falls right into place as the exact reverse. No extra mental heavy lifting required.
Next up, we have those super intimidating sum to product formulas, where adding 2 signs magically turns into multiplication. But honestly, it's really just about 2 things, the middle and the difference. Just imagine two kids standing at two different angles. To relate them, we simply find their middle ground by adding them and dividing by 2, and then we find the distance between them. That's the core logic right there. Middle plus distance. When you look at the math this way, these crazy equations start feeling incredibly intuitive.
Section 5. Building sine from scratch. Now we are going to push past triangles and circles entirely. We're stepping into the beautiful, vast new world of calculus. In this world, we calculate sine not with shapes, but by using infinite series of very small pieces, measured in radians. Let's look at this step-by-step Taylor series progression. I actually love to think of this as building a toy. Step 1, we make a rough guess. For a very, very small angle, sine of x is roughly just x. But it's not perfectly correct, so step 2, we fix that guess by subtracting a tiny piece. Still not absolutely perfect? Step 3, we refine it again by adding an even tinier piece. Each new piece makes our answer better and better, and suddenly, a deeply intimidating calculus concept just feels like a simple construction project.
Section 6, the trigonometry family tree. Let's start connecting everything.
All right, let's take a step back and look at the massive macro-level takeaway here. We started this explainer with a pretty major problem, right? Staring at a chalkboard with 20 chaotic equations. So, the big question, do you really need to memorize 20 completely independent formulas to understand trigonometry?
Well, the crucial point is absolutely not. No way. You only need 4. Trigonometry is not a giant bag of disconnected math problems. It's this elegant, beautifully flowing system.
These 4 foundational parents are really all you need. Parent 1 is the circle, represented by our little toy robot. Parent 2 is adding 2 angles for sine. Parent 3 is adding 2 angles for cosine. And parent 4 is tangent, which remember is just upward movement compared to sideways movement. That's the whole shebang. Almost every single other formula we've explored today, from those tricky double angles all the way to calculus series, can be organically built and derived straight from these 4 core concepts. Which brings us to our final thought for this explainer. I mean, think about it. Can deep physics really come from a simple turning arrow? Isn't it absolutely amazing that the deepest mysteries of calculus, engineering, and quantum physics are essentially just mathematical extensions of a little arrow turning in a circle? It's wild. Once you start to see these patterns, you realize the universe has an incredible, beautiful underlying order to it. Thanks so much for joining me on this explainer, and definitely keep looking for those hidden connections out there.